Let P be the point with given coordinates and pi be the plane with given equation. Let P prime be the reflection of P in the plane pi. Find coordinates of the point P primed. When P primed is the reflection of P in the plane, this plane acts like a perpendicular bisector of PP primed. So line through PP primed is perpendicular to the plane, and distance PM is equal to distance MP primed, where M is the point of intersection between line and plane. So the position vector of the required point P primed can be found as vector OP plus 2 times vector PM. So we need equation of the line through PP primed, then we need position vector or coordinates of this point M, and then position vector of this required point P prime can be found. Or another way, you can write the equation of the line through PP primed as OM, it's very important, OM plus some parameter times direction vector, and since position vector of point P is given, we can find the corresponding value of this parameter lambda, and let it be, for example, 10. Then lambda corresponding to the point P primed will be negative 10, and substituting negative 10, it's just an example, you can find position vector of point P primed. So let's write the equation of the line through PP primed. We need position vector of any point on the line. We can use this. Plus some parameter times direction vector, and since normal to the plane is parallel to the line, we can use normal, and components of normal are in front of x, y, z in the equation of the plane 1, 1, negative 2. In general, we can take any multiple. Then we need coordinates of a point of intersection of this point M, and it can be found substituting x, y, z in terms of lambda into equation of the plane. So 1 plus lambda for x plus y, y is lambda, minus 2 times z, minus 2 times negative 2 minus 2 lambda, plus 3 is 0. It becomes 1 plus 2 times lambda plus 4 lambda plus 3 is 0. 6 lambda is negative 8, so lambda is negative 4 over 3. And substituting negative 4 over 3 for lambda into this equation of the line, position vector of point M can be found. Let's write that it's equation of the line through PP primed. So we get that O M vector becomes 1 minus 4 over 3, 0 plus negative 4 over 3, and negative 2 minus 2 times negative, so plus 2 times 4 over 3, which is 3 over 3, so negative 1 over 3, negative 4 over 3, and it's negative 6 over 3 plus 8 over 3, it's 2 over 3. And hence OP primed vector becomes OP 1 0 negative 2 plus 2 times PM, and PM can be found as we can consider coordinates of a point M as negative 1/3, negative 4/3, 2/3, and coordinates of a point P is 1 0 negative 2, and hence components of a vector become coordinates of the endpoint minus coordinates of the starting point. So it becomes negative 1/3, negative 4/3, 2/3, minus 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 1 0 negative 2, or PM vector is OP, not OP, PM, it's OM minus OP. It's directly difference for vectors, or you can use a triangle rule for the sum. PM move from P to M, so it becomes PO plus OM, and PO it's minus OP. And it becomes 1 0 negative 2 plus 2 times, it's what, negative 4/3, negative 4/3, and 8/3, which is, it's 3/3, 0, negative 6/3, plus minus 8/3, minus 8/3, and plus 16/3, which is negative 5/3, negative 8/3, and 10/3, and hence coordinates of a point P primed become negative 5/3, negative 8/3, and 10/3. And that's all for this question.